Okay, guys, let's get started. So, today our agenda will be to continue on the discussion that we were doing last time. So, we were doing a demo on Langchain. I gave you a brief example of how OpenAI API works. Although we did not focus much on that because we wanted to jump to Langchain and build a simple RAG application on using Langchain. So, today we are going to do that. We will use our OpenAI API key and use Langchain to connect to OpenAI API, and then we will use um, different features that are available in the Langchain to build a very simple RAG pipeline. But before that, before doing that, there's a lot of work we need to do. Especially, we need to understand how the Langchain library works. Okay, so again, we'll not go too deep into the Langchain functionalities, but we'll try to understand what are the different things, how it works, how are we going to write code. There is a LCEL expression language that Langchain uses, where we can use pipe operator to connect different components, and we'll also try to understand about the concept of runnables, and then how are we going to use chunking, embedding, vector store, retrieval, all of that. And we'll build a basic RAG pipeline first. If we build the basic one, then we will further discuss on how to improve it. That is the agenda for today. So let us get started. Just give me 1 second. Okay, so let me also keep the Langchain docs side by side because I will be referring that. Okay, so today we will focus on the chat prompt template. Okay, and let us see what is this chat prompt template and not chat prompt template. I'll just give you a direct example and we'll spend some time. We may not reach to building RAG today, but we'll try to at least understand most of the basic things. Okay, so last time I gave you a very simple example where we took a API key. Actually, my API key is also expired. I deleted that. Let me give me 1 second. So what I will do here, I'm going to store my API key. I'll show you. Okay, so if I come to my folder where I'm working, which is where am I working? Documents, code, where are community sessions, agentic AI, and here I have this folder, and in this folder I'm going to create one file which will be .env file. Okay, I'll come here and I'll keep that as a .env so that every time I don't have to constantly keep deleting it like that. So here is my, you see, I'll show you. Here I'm creating this .env file, and inside that env file, I have created one key like this, OpenAI API key, and I'm going to. You can use config also, Anubhav. You can use config also. Okay, so I'm going to copy my uh, key and I'm going to paste it here. Okay, like this, and create a .env file, and then we will use a .env loader to save that. Okay, so I'll show you that. This is just one time process we need to do, and after that it will be set. So let me open. You can use config and then toml. Using that also you can read, but a very good way to do it is using environment variable. Okay, later on if we are deploying the applications, we'll use things like secret manager that I will show you when we get there. Okay, So I'm just going to paste my API key there, and let me save it. And let me come back here. And what I'll do is I'll just do import dot env. Okay. And let me do a load dot env. Give me 1 second. What's the syntax for that? Load from, it is from dot env. I'm going to import load dot env, and then I'm going to call this load dot env like this. Okay. And then if I come here and if I do, this is giving me true, which means my environment variables are loaded. Environment variables basically are everything that is there in your env file. So you're not able to see the env file here because it is hidden. So it's not showing in your Jupyter notebook, uh, Jupyter Lab Explorer, but it's there as a hidden file. If you come here, you will be able to see there's a .env file. I hope you guys are able to see this. Okay, so it will be there. You can keep it. You can take it from there. And if I just do a import OS, and from OS, if I do OS dot mm, get env, OS dot OS dot get env, and let me do OpenAI API key, OpenAI underscore, and you should name it exactly like this because this is what they expect. So you'll be able to see my key here. Okay. So I should do just 5 here. So this is my OpenAI key. So now OpenAI key is there in my environment variable. So what I can do, I can delete this and let me put this on top so that you know that these are the things we need to download. Let me move this here. Okay. And I'm doing OpenAI chat OpenAI this, and here I don't have to pass this anymore because it is there in the environment variable. And let me run this also. Let me run this also. And if I run this, and then if I do this, you see I'm getting my answer. So you see here I'm having this LLM, and I'm doing this llm.invoke. I'm passing this prompt, and from the prompt, I'm able to get the content. This is the basic setup that we need to do. Okay. So now we'll move ahead and we'll try to explore a few of the features or few of the benefits on why we want to use this Langchain library. And there are a lot of different things. I'm not going to give a demo of every single thing, but we'll start building. And as we build, you will get an idea of what I'm talking about. So the first thing that I want to show you is a prompt template. Okay. So what is the need for a prompt template? What is a prompt template? You see that when I'm writing a prompt here, okay, it says, tell me who wrote the Constitution of India. So this is what we will say. This is a hard coded prompt where Constitution, India, whatever we want to say is hard coded. It's not module. It's not, what do you say? It's not flexible. Suppose if tomorrow I want to build an application where we want to find out who wrote the constitution for different countries. So instead of India, I will want Australia, or instead of India, I will want Pakistan, or Nepal, Bhutan, Russia, America, whatever. I want to change the name of the country. Okay. Or suppose if my uh, prompt is that I'll say generate, tell me a joke on physics. Suppose I want to build an application where a user will enter a topic and he can generate a joke on that topic. So the topic is going to change. So here it is, tell me a joke on physics. Tomorrow I will want to say that tell me a joke on chemistry. Okay. So I will want this physics and chemistry to be variable. And I will not just need one variable, two variables. I'll need multiple variables. And this you should be able to relate to RAG, because when we are doing RAG, we will have context and question that will always keep changing, and there will be some instruction which will be constant. So in order to manage that, in order to make the prompts little bit flexible, we have this chat prompt template. You can understand this like f strings in Python. In f strings, you write a string and you keep placeholders, and later on you can pass values to that placeholder. This is something very similar to that. Okay. So I will come here and let me import. I will say from Langchain underscore core import chat prompt template. core, sorry, Langchain core. I'm going to dot prompts. So recently they have changed a lot of these things. So I had to refactor a lot of code. Um, Chat prompt template. Okay. So this is the chat prompt template. And now what I will do, I'm just going to create a template. I'll create a template. And I'll say template is nothing but tell me a joke on, and I will say here topic. Okay. Okay. And I'm not giving the topic. Topic is something that I will pass probably later. And here I'm going to generate a prompt. Okay. So prompt is going to be a little bit dynamic, just like how we have f strings. So I'll say chat prompt template. Okay. Chat prompt template from template. And I will say topic is equal to physics. Okay. So now if I come here and if I look at my prompt, uh, chat from template, sorry, this will be here and to pass template. Okay. So this is my prompt. You are able to see the prompt, and here I will come and say prompt dot format, and I will say prompt dot format, and I will pass here topic is equal to physics. Okay. So now if I come here and if I look at my prompt, you can see here, I will have topic here, and this is my prompt, and I'm formatting the prompt, and I'm saying that tell me a joke on physics. So depending on what I pass here, my prompt has been modified. Okay. Now what I will do, this is my chat prompt template. Now I will create a chain. What is the purpose of doing a chain? The purpose of doing a chain is that I will create something like what happened. Okay. I'm going to create a chain where I will pass some input here. This will be a call or some processing, and whatever is the output of this will go to some other process. Okay, maybe this is also LLM, and this is also going to the output of this will go to some other process. Maybe this will be a parser. Okay, it will go to some other thing. So like that, I'm going to create a chain. So in Langchain, we are able to create a chain using a pipe operator. I'll show you this using example. You will understand it better. Otherwise, it's difficult. Okay, so what I'm going to do, I'm going to say that I'm going to create a chain, and chain will be, I will say I will have a prompt. Okay, and that prompt will go to my LLM. So where is my LLM? My LLM is here. I've already defined one LLM here. Okay, so let me take this and let me bring it here. Okay, this is my LLM. I'm saying I will create a prompt. I will give some input. That input will modify my prompt. Basically, I will give a topic. That topic will go to my prompt. So this will be my prompt. Okay, I will pass one topic here. It will create the prompt. Here I've created a very simple prompt, but it can be a very detailed prompt. That example I'll give you. And the output of the prompt will go to the LLM. Okay. When the output from LLM comes, I want to do something else with that. Maybe I want to translate it. So it will go to a translator. Maybe the LLM is giving the answer in English, but I want to translate to English or Hindi, or I want to parse it. I want to convert it to a JSON. I want to convert it to something. I want to clean it. Whatever I want to do, I want to do some process. So I'm going to create a chain. So you see, this is one chain. So in a lang chain, I'm going to write it like this. I will say prompt. Prompt will go to my LLM, and LLM will go to my translator, parser, whatever, like this. This I will create a chain. And when I'm executing the chain, I will pass whatever information is needed. So this prompt is actually needing one topic. So when I create the chain, I will pass the topic. It will create the prompt. Whatever is the output from the prompt, it will go to the LLM. Whatever is the output from the LLM, it will go to the parser. And further, if I add more things, it will be there. Otherwise, in the end, parser will give me the final result. So I will create a chain step by step. Things will add up. Okay. Is everyone following? Ajita, Rajiv, Shashwat. Okay. So here I have a chain, I have a prompt. Here I've created a very simple one, just prompt and then LLM. Okay. So now what I will do, let me do this chain dot invoke and chain dot invoke, and I will say my topic is equal to, I hope this works because Langchain has changed so much that, okay. Topic, this has to be a dictionary, I think. Chain is not defined. Okay. So I'll create this LLM, I'll create this chain. You see what is going to happen. So you see now the chain has invoked and I have passed a topic which is physics. Okay. So you see here I'm getting the joke. I'm having one content. Why did the physics teacher break up with the biology teacher? Because there was no chemistry between them. So this is a joke on physics. So this is the content, and here you can see there is a lot of metadata also, like how many tokens were used, and how many tokens were there for prompt, how many total tokens, okay, completion tokens, prompt tokens, and then there are a lot of other details which we don't want to see all of these things. So what we want prompt. After prompt, we want the LLM. After LLM, we want to do some parsing. Parsing means I don't want to see this thing. I just want to see some meaningful result. Okay. So let us do one thing. Let us create this chain in a slightly different way, and we want to add a parser or string. There are different types of parsers in Langchain. We are going to do a we add a parser to the chain. We want to do a string output parser, which means Langchain already has this inbuilt, where if we add a parser, it will take the output of the LLM and it will give the string component of that instead of giving me one AI message. So here what I'm getting is the AI message, but I don't want the AI message. I only want this part. Okay. And I don't want to do that again and again. I want to build that in a automated way. So I'm going to create one chain. I'll say prompt LLM. After LLM, I want to add one more thing, and that is called as a string output parser. So I'll come here and I'll say from Langchain core dot output parsers, Langchain core output parsers. I'm going to import string str output parser. Okay. So what I will do, I'll create an output parser. You'll see after some time how doing these things will make your life very easy. Output parser, and this is my string output parser. Okay. So I now have an output parser. What I will do, very simple. I have a prompt. I have LLM. After LLM, I will simply add one output parser. Okay. So now I have created my chain, and now I'm going to do the same thing here. I'm going to say chain dot invoke topic physics, and you will see now I'm not getting this AI message. Instead of this AI message, I'm getting a very nice string. Okay. Is everyone able to follow up till here? What is the need for this chaining? What is the need for this prompt template? Are you able to understand that? Okay. Now what I want to do is that I want to add one more thing here, which is I don't know if I'll be able to do that, but I want to translate this to some other language. Okay. Can we do that? Can we try to do that? I want to add one more component here. Okay. Which is, let me take this. Okay. I want to add a translator uh, step after the output parser. Okay, and in translation also you can keep the control. Like for example, you want to translate it to English, Hindi, French, German, whatever. So basically you will give a topic. That topic will get into the prompt will go to the LLM will go to the output parcel will give you a string. Now you have one string as a joke. Now you want to convert it to different languages. That is something that you can do. So what I will do here, let me create one translation prompt. Okay, so my translation prompt, let me create this. I'll say chat prompt template, and I'll say from message. Okay, and here let me add, I will say system. Okay, and I will say that, let me give some prompt here. I'll say you are an expert at translating translating jokes from to any language to Hindi. Okay, so please translate the given joke to English. Okay, something I'll add like this, and then I will pass here something like, I'll give a comma and I will pass that this is the system prompt, which means I'm telling the LLM how to behave, and then I'm saying that I'm a user, and as a user I'm going to give you the English input. Okay, so I've created one template here, translation prompt, and what I will do now is, what I want to have this chain. I hope this works. I will have this chain, and I will say that the output of this output parser should go to the translation prompt. I will create a new prompt, translation prompt. Okay, and this translation prompt should again go to the LLM, because translation also LLM has to do. And whatever I'm getting from this LLM, let me see if that works or not first. So I'll take this chain and let me again create this chain dot invoke. Let's see if that works, if it is automatically passed or not. Mm, let's see. Uh, chain dot invoke. So I'm having this translation prompt. AI message, physics do not like response to English. Okay, sorry. Given joke to English, not given joke to Hindi. Sorry. Let us see if it works. Okay. So now you can see here that we are getting this joke in Hindi. For those of you who can read Hindi, you will be able to see this. Okay. But you see, again, we are getting this very irritating AI message. So we already know, if we have output from a LLM, how do we convert that to a string format? We know that there is an output parser. So what I will do, I will again take this and I'll put it as a output parser. What I'm trying to show you is that how easy it becomes if you're following this expression language by Langchain, where you can pass one input, the output from that process is given to the next step, and like that we create a chain. And if you have defined one entity once, it's very easy to plug and play. Just like Lego blocks, you can plug and play. If I have defined one output parser, I'm able to use it again and again. So it makes your code more modular, it makes your code more flexible, and it's very easy to make the changes. You don't have to go and write the same thing again and again. You don't have to define your own classes, you don't have to define your own functions, although you have freedom to define your own functions. But for common things, there are already pre-made modules that are there in Langchain, which we can reuse. So very simply, you see, if I was not doing this, then I will have to save the result of this thing in one variable, then call dot content on that. So it becomes a lot of redundant code. But here I've just added this output parser, and if I run this, you will see that I should be able to get one string joke here. Now I can come here and I can take this, and simply instead of physics, I can do mathematics. maths, and I will be able to generate a joke in Hindi in maths, which is first generated in English, then it is um, generated in English, then it is converted to Hindi. So this is a very simple example of how LCEL or how Langchain is working. So I'll write here. We now know how to use LCEL. There are a lot of things in LCEL, but I'm just giving you the basic LCEL and chaining in Langchain. Shashwat is saying that, sir, you asked it to translate. Acha, that was a mistake. Why did you add the LLM after the translation prompt? We could have directly used output parser. नहीं, directly use output parser नहीं ले सकते. Output parser का काम है कि उसके पास एक LLM output होना चाहिए. That LLM output will be converted to string. So we will first create the prompt, because in the prompt we have to tell what it is supposed to do. That prompt will go to the LLM. LLM will give me an AI message. That AI message will go to the output parser. Then only we will get the result. Did you get it, Shashwat? आउटपुट पार्सर का काम है एक एआई मैसेज को स्ट्रिंग में कन्वर्ट करना. एआई मैसेज कहां से आएगा? एलएलएम से आएगा. एलएलएम को क्या चाहिए? एलएलएम को एक प्रॉम्प्ट चाहिए, तो हम उसको पहले प्रॉम्प्ट देंगे. प्रॉम्प्ट को क्या चाहिए? प्रॉम्प्ट को जोक चाहिए. जोक कहां से आएगा? आउटपुट पिछले वाले एलएलएम के कॉल का स्ट्रिंग चाहिए. सो फर्स्ट विल गिव द प्रॉम्प्ट. First, we'll give the topic. That topic will complete the prompt. That prompt will go to the LLM. It will generate the English joke, but in an AI message format. AI message will be converted to string using this output parser. That will go to the translation prompt. In this translation prompt, we are saying that you are an expert at translating jokes from any language to Hindi. Okay. That will further go to the LLM, and that will further go to the output parser. Now we can customize it further. Suppose we want to see the English joke also, and we want to see the English joke and we want to see the Hindi joke. Both we want to do. So, or we want to do the translation in different languages. For example, here I'm giving topic, but at the same time, I also want to give, what do you say, the language. Here we are converting to Hindi, but I want this Hindi also to be flexible. I want it in Japanese or German or something else. So those things also we can do. We'll get into all that later, but we have all the flexibility so that you can create a very flexible system. Okay, it's not that you cannot do these things without Langchain. You can do these things without Langchain, but you will have to write a lot of unnecessary repeatable, lot of repeating code. You will have to create your own modular structures, which is very difficult. But if you use the Langchain or LangGraph library, these things become very easy. It becomes very simple. Okay. So this is one building block that you need to know in order to build a simple RAG application. So now let us move ahead. Okay. So we learned about prompt templates. We learned about chaining. Runnables we have not learned, but anything that we are using this invoke method, okay, that is a runnable in Python, runnable in Langchain. Don't worry about it. We will get to that in a while. Okay. So let's use this concept to create one prompt, create a basic context plus question prompt for Langchain from in Langchain. Okay. So if you remember when we were doing the discussion, I told you that when we are doing a RAG application, okay, let me come here. Let me revise that a little bit. Okay. We'll go step by step, but the basic thing that we discussed was that we will have a LLM and we will ask it a question. And this question will also have some context. Of course, we discussed that this context is going to come from a knowledge base. Okay. But right now, we want to skip all that knowledge base and all. We'll just assume that we have the context and we have the question. And we will see that if there is a context and a question, is the LLM able to give a response? Okay. If the context is not there, then how does the LLM behave? If the context is there along with question, then how does LLM behave? Okay. So if we are able to prove that if we give a context and a question to the LLM and we are able to get the response, then we can further work on creating a better context using documents and embeddings and all of that. So okay, so we'll work on documents and embeddings in little later, but first we'll just hard code some context, and we'll see if we are able to get an LLM to answer some private questions or some questions about which LLM will not have any knowledge. Okay, that's one proof of concept that we will do quickly, so that you are convinced that LLM does behave better if we give context. Okay, so that's the idea. So what I'm going to do, let's come here and let's say, let me create one template. Okay, okay, this is template, and I will give a template here, and I will say that i'm going to I'm going to do a system message. So system message is that I am going to provide you some information, some context, and then ask you a question. Okay, I'm talking to the LLM. I'm saying, you are supposed to answer the question based on the context. Okay, if you can't answer the question, then say I don't know. Okay, don't make up an answer on your own. Okay, so I am writing a very casual prompt, but if you go on the internet, you will find a lot of good prompts for retrieval or for RAG or to make the LLM answer from the context, that you can Google and you can find out. Here I'm giving you a very simple example. So I'll come here and I will say context. Okay, so context is equal to, I'll say context, and I will come here and I will say question is equal to question. Okay, so I'll give the context and I will also give the question. Of course, context will come from some other place. Right now I will just pass it on my own. Before doing this, I will also show you that how does it work without the context. Okay, I'll come here and I will say prompt. Prompt is there, so I'll create prompt will be chat prompt template, and I will say from template. We can do from template or from message. I have shown you both example earlier. Okay, so here I'm going to give template. By the way, please don't try to think that how I am writing all this code. I have not memorized anything. I'm seeing one screen on my right side. I have the code which I was copy pasted from the documentation, and I'm seeing that and I'm writing. Okay, I have not memorized anything. If you take out my reference page, I will not be able to write a single line. I so don't, in your mind, don't think that okay, I have to memorize all these things. Never ever try to memorize it, because these things will change every 3 months. Okay, if I write a code after 3 4 months, Langchain does some changes, and the code works, but the new way comes. There's updates in the library, which which will make certain syntax obsolete. Okay, it becomes like an older version, so it keeps getting refactored. So I know many of you must be thinking that how do I memorize from template and chat from template and string output parser, all of these things. Don't worry about memorizing anything, just copy paste from the documents. Okay, so I'm going to create one prompt here. So I will just, there's no need to do this, but create let me just have this prompt. Okay, so now what I will do, I will create one chain, and chain will have prompt, and I will have LLM. I'll And after the LLM, I will have one output parser. Okay, so let me create one prompt here. Prompt. Let me create prompt with context. Okay, let me create another template. Template. Let me have one template with, or let me just have it like this. Okay. I'll just say, come here and say without context. Without context, I can say LLM dot invoke, and I can say what is my favorite food. If I ask this question, um, let us see what happens. If I do str output parser, what will happen? Just for fun. mm, mm, mm. ये मैसेज नो, ऐसे नहीं होगा. Let me say, okay, let me just keep it like this, the response, and I will do response dot content, response dot, yeah, content. You see, it says, if I don't give the context, it is say that I am sorry, but as AI assistant, I am not able to determine your favorite food. Can you please tell me what your favorite food is? So the LLM does not know about what I like, what I don't like. Okay. Now what we will do, this is without context. Now we will use a simple RAG to allow LLM to answer some private questions. Okay. So now what I will do, I've created a template. In that template, there is a space for context also, question also. So I've created this prompt, then I'm creating a chain. Okay. Now in this prompt, I need to pass, in the prompt, I need to provide context along with the question. Okay. So what I will say, when I'll say chain dot invoke, okay, let me create some context here. Let me create some context. Okay. So context is that it is maybe coming from some book. I'll say, hello, my name is Ram. I live in Hyderabad and I am a software engineer. I like to eat pastas and other Italian food like pizza. I like, let me create this as a, like this. Okay. So right now I'm giving a very short context, but actually when we have a huge context, we will have to use documents and chunking and all of that we will have to do. But right now we are just doing a very simple one. Okay. I like to eat pastas and other Italian food like pizza. I like spicy food. And I also like to cook Indian food. Okay. So this is the context. So now you see when I will ask the question, what is my favorite food? So here the LLM does not know who is my, who is asking the question. Okay. So that's why I'm saying here that my name is so and so, and I'm living here. And then I'm telling about myself that I like to eat XYZ food and some description I have given, and you can add more things here. Okay. Let me add, I also like to eat biryani and coke. Okay. So this is my context. Now what I will come here, I'll say come here and I will ask the question. I'll say chain dot invoke, and here I will say that I have a question. Okay. So here let me add a question also. So the question is that whatever question I asked earlier, what is my favorite food? What is my favorite food? And here I will come and I will say question is question. Okay. This should go as a dictionary actually. Question, and I will say I have some context. Okay. So suppose I am not giving any context. Suppose I'm not giving any context. I'm giving plain context. Then let us see what happens. See, it is saying I don't know. Because LLM does not know what is my favorite food. And I have told the LLM that if you don't know the answer, then you are supposed to say that I don't know. That's why the chain is saying that I don't know, because I've not passed the context. Will the tokens be used even if we don't provide context? Could we better utilize the tokens by keeping check for the context to be present? What do you mean? Tokens will be used if we don't provide context. Tokens will always be used. LLM does not know what you are doing. LLM only knows the block of text that you pass. Context, question, all of these things are human things. LLM does not know. If you're passing not if you're passing context, then this whole thing will be added to your tokens. If you don't pass context, like I did not pass any context, then that will not be used. Tokens is only based on the amount of information that you are giving to the LLM. Okay. If context is big, tokens will be more. If context is small, tokens will be less. Here there is no context. I passed the empty string, so that will not be added. Did I answer your question? Okay. So now what I will do, chain dot invoke without context. The LLM will say, I don't know. Okay. Now what I will do, I will take this and I will pass it. Let me put this also. Okay. Let me run this. It is saying, I don't know. Now I will take the same thing, and instead of passing empty string, I'm going to pass my context. If I pass my context, now the LLM should refer to my context and it should give some answer. Okay. So let me come here again. Let me take this. Let me put it here. See, now it says based on the context provided, your favorite food is pizza. So can you see that it is able to see information from the context and it is able to give me the answer. Now I can add some more question here. I can, uh, instead of question, I will say, tell me, describe. I'll say, describe my food preferences. Also, tell me if I like Japanese food or Asian or Japanese or Japanese food or French food. Let's I'm just playing around to see how much it is able to answer. So it is saying based on the context provided, your food preferences include Italian food and pasta and pizza, as well as Indian food like biryani. You enjoy spicy food and also like to cook Indian dishes. Additionally, you mentioned enjoying Coke as a beverage. As for Japanese food and French food, based on the context, it is not mentioned whether you like or prefer these cuisines. So the answer is I don't know. Okay. So you see, there are two questions in my question. The first question is to describe the food preferences, and second is to tell if I like food, French, Japanese food, or French food. Okay. So I have not mentioned anything about Japanese food or French food. So the LLM is not hallucinating. It is not making up any answer. So it is able to give me this question. If I pass the same question again, and if I remove the context, if I remove this context, and if I don't pass anything, let us see what happens. Again, it says I don't know. Okay. Now you can play around with it. You can try to remove this line, that if you can't answer the question, say I don't know. You can remove this line and then you can see that what LLM says. Okay. Maybe it will try to make up something. If you run it multiple times, it will give you some random answers. Okay. And here I've also given a strict instruction that do not make answer on your own. So you can remove this part also, and then you can see that what happens if you remove these things. Okay. So this is a very, very simple example of a retrieval augmented generation, where we are giving some context and LLM is taking information from the context and giving to the LLM alongside the question. Okay. So if you see here, what is the prompt, if you look at this, okay, let me come here and let me show you that what is the prompt, what is the LLM seeing. As far as LLM is concerned, prompt dot format. Okay. It is going to see things like this, prompt dot format, and I will say here, see, context is equal to context and question is equal to question. If I do this, you see, let me print this. Okay. So see, as far as LLM is concerned, this is the prompt that is going to LLM. Okay. So the LLM is seeing that, okay, I'm going to provide you context, blah, blah, blah. You are supposed to answer. If you can't answer, say, I don't know. Don't make answer on your own. There is context, and here is the context that I'm passing, and here is the question. So this is the LLM. This is what LLM is seeing. So LLM is going to calculate the tokens based on this thing. Okay. You can simply also do here LLM dot invoke. Okay, you can also pass here like this. You can also do this. Okay, so here you will be able to see the content, this content here. Okay, and you will be able to see how many tokens I'm using here. So prompt tokens, completion tokens is 14, prompt token is 130, total tokens 134. Okay, see, prompt tokens, completion token is 13. So the answer that it has given, that is 13 tokens. The question that I gave, the prompt that I gave, that was 130 tokens, because obviously it is a little bit big. Okay, and then you have all these other details which you can see, but I don't want all this, so that's why I am not using this method, rather I'm using this chaining method. Now the thing is that here we have created this context like this, but actually the context is not going to come like this, how where I have just typed it. It is going to come from some documents, from some PDF files. So for that we need to read those PDF files and create a document, create the embeddings, and then we have to create a system that will extract the right context. Once we have the right context, then that can go inside this template. So I've shown you the last part. Once we have the context, how things are going to work, that is what I have shown you. But now what we have to see, we have to see this part. I've explained it earlier, right? This part, this thing we have to do, where we will take some document. From the document we'll do chunking. From the chunking we'll create embeddings, and these embeddings will be there in a vector database, and this vector database will also act like a retriever, where we will pass the question, we'll take the query, we'll create the embeddings of the query, we will pass that query to the vector database. The vector database will find out top k most similar documents. That similar document will be returned as a context. Okay, this context will be there. This context will be passed to the LLM along with the question, just like how I showed you. Guys, did you understand? राहुल पांडे, राजीव, समझ में आ रहा है? Is there anything you did not understand? Can we move ahead? Chalo. So let's look at some other components of Langchain. So which is document loaders. So what will document loader do? Document loader will allow us to read some document. So let us not do document loader also. Let's do chunking and embeddings. Okay. And then in the end we will do document loader because it's the last part. So the next objective in our discussion is to take a large context, take a large context and chunk and embed it, chunk and embed it, and use a vector database to retrieve. Okay, so we'll take a large context and we will split that context into small pieces. For every small piece we will create one embedding, and that piece and that embedding we will store it in a vector database. This much we will do. Okay, if we are able to do this, then the last part will be to read a document. So if we read a document, from the document we'll get a large context. From the large context, all the other process you already know. Okay, this is the whole process. Vector database to retrieve, we'll say retrieve, we'll take a large text information and to retrieve the context, let's call the context as the final thing. Okay, so this is what we are going to do. So in summary, we want to extract this information. Here I have written down this thing, but if you imagine that if this was my biography is going to have 100 other things, right from the point I was born till the point I die. All my life details are there in my biography. So in that, in some chapter, in some paragraph, I will mention what food I like. So there are going to be hundreds or thousands of pages. Thousands of pages will have 10,000s of paragraphs. In all those paragraphs, we have to find out these 3 or 4 sentences. That's the task. Okay. How do we use existing embedding model to embed? Can we, guys? Are you guys saying something I'm not able to hear? Is something wrong with my speaker? Can someone unmute and talk? I want to make sure that you guys are.
Yes, sir.
अच्छा ठीक है ठीक है. Someone is asking, how do we use existing embedding model to embed? Can we make our own embedding model? Both you can do. We will use existing embedding model. If you want to create your own embedding model, you can do that also. We can do that also, but we'll do that probably later. Right now, we will use existing embedding models, which is there in OpenAI. Okay, so LLM also we are using OpenAI. Embedding also we will use OpenAI. But you see here in this entire code that we have written, there is no mention of OpenAI. We are just using this LLM object. Okay, tomorrow if you want to shift from this LLM to some other thing, okay, that also we can do. If you want, I can give you a demo of that also. Probably little bit later I will show you. Let me add it here. Mm, I'll give that info, show that also, that how to use a local running LLM to build this RAG. So suppose you don't want to pay for OpenAI, or you don't want your information to go to the internet, or you don't want to pass your information to GPT. So you can download some of these small LLMs. Of course, GPT is a huge LLM, but you can download some small LLMs which are having less number of parameters, and you can run it in your local system itself. Okay, it will work a little bit slow, but you will be able to run some of these LLMs locally, and you can use those local LLMs also inside uh, Langchain. Okay, Shashwat is saying you had mentioned this, that one of the features of Langchain to be able to work with different LLMs with simple snippets. Not even simple snippets, just like one line of code you have to change. Okay, I'll show you one. I'll give you one example. Okay, before we move ahead, I'll show you one simple example. That what you can do here is I can use Olama. If you go here, you'll see there is something called as Olama. So Olama is a very easy way to use open models, open source models. GPT is not an open source model, so you have to use API calls. You have to connect with OpenAI and using API key, and you have to pay for all that. But there are a lot of LLMs which are available for free, which are open source, which means their parameters are open, they are available. For example, Google has a Gemma, or Llama is there, Lava is there. Some of the Mixtrals are also, I think, open source. So you will be able to find all of these models on the internet. And Olama is a tool that will allow us to run these LLMs locally. Okay, some other day I will show you how to build this, run this Olama, but I will show you one small demo. If I come here and if I look at, let me open one tab. Okay, so I have this Olama installed. Okay, you see, I have this. I'll show this to you later, but today I just want to show you that what models I have. So Olama, if I do list, you see these are some models that I have. Like I have this Gemma model, which is from Google open source, and I can use like Llama and other things I can pull. Let me show models here. If you come here, you will see that some of these models are available. Let me do Llama. I don't install it because it takes a lot of space in my hard disk, so I delete it. But you can see there is Llama 4, Llama 3, Llama 3.2. If you want like vision models, there is Llama. There is also Lava. Okay, so you can download these models and you can keep it in locally in your system, and then you will be able to run it locally also. So I have this, and Python actually supports this. Langchain also supports this Olama. So let me show you one small change, how easily I can make this change. I can come here and I can just say that from Langchain, uh, Langchain underscore Olama, I'm going to import olama.llms. I'm going to import chat Olama LLM. Okay. So now what I will do here, you see I'm creating one LLM like this. What I will do is here I will create one LLM in a very different way. I will say that my LLM is equal to Olama LLM, and I will pass my model. So I have a model. This model is very bad actually, but you can use any model you want. I have this model called Gemma. Let me take this Gemma model. I'll show Olama in a little bit detail in some other video. But today I just want to show you that if you want to change your LLMs, it is very, very simple. That's what I want to show you. Okay. So I'm creating this LLM. And now once this LLM has created, okay, you can again run the same line of code. See, only one line has changed, and you can run this line of code and you will be able to get the response. It is little bit slow because it is running in my laptop. My laptop does not have a lot of this thing, but let us see response dot content. What happened? You can see here there is a response. This is coming from the local LLM that is working in my system. So this LLM is now working fine. I can come here, and this is not giving me the AI response like how it is coming from the other one. Mhm. Because if I use this one, then this is slightly different. Because this is a chat model, okay? That's why it is like behaving like that. And that is a text completion model. That's why it is not giving me AI message. But you can come here, and if I do response dot content, okay, so you can see here I'm getting this like this itself. Here response itself is giving me that it does not have any content key. Let me do this type on this. Is it a string? No, this is the AI message only. Oh, but no, sorry, this one. I think this is a string. Sorry, I'll have to do LLM like this. This should be a string, I think. If I do a type, yes, it is a string. That is, there is a difference, a small difference that I will tell you later. That this is a chat framework. So in chat, there is a concept of human message and LLM message. But in Olama, this is a text completion one where it is just completing the text message. So there is no role play of user and the chat. That's why it is not giving me AI message. It is directly giving me the string. So don't worry about that. But the idea is that LLM can be swapped. This is chat OpenAI. Tomorrow I want to shift to Anthropic. We can do very easily. Once you change that, remaining code I don't have to change. Remaining code I don't have to change. It will be as it is. So let me try that once and see if that works. Let me come here, not this one. Let me come here and before doing this, I want to say try the chain using some other LLM from Olama. Okay, so this is my experiment, and let me bring everything here. Let me bring the template. Let me bring the template. I have the prompt, I have the chain. Let me bring the LLM also so that you can see it. Oh, guys, it's already 4 o'clock. I have to start the other meeting. Just quickly, we'll conclude. Let me put the message on the WhatsApp group. Okay, so let me. Where is my LLM? Olama LLM. This is my Olama LLM. Let me take this, bring it here. Okay, and what I need to do more? This is my chain, and I can come here and I can create this chain here like this. Okay, and I'm going to invoke this chain. Let us see if it works. See, it is working. Here the LLM is coming from Olama LLM. instead of this LLM, I can switch very easily. I can do this also. Where is my LLM? Other LLM chat open. Okay. So you can come here like this. I can run it. This is also working. And I can switch from here to here. This is also working. It's a very simple example. It's a very simple example. But it will show you when you're writing bigger code, you don't want, because chat OpenAI is paid. So if you're using a lot of tokens, you will not want to use chat OpenAI for everything, right? So you can create like one uh, OpenAI LLM. You can create one Llama LLM. You can use Llama for cheaper things where you don't want a lot of reasoning, you don't want very good quality result, but you want it to be cheap or free. You can use one LLM, and in other places you can use other LLM. Or what you can do is you can create a cheaper version, but you, if you are not satisfied with the output, you can switch to the expensive version, which will give you better quality output. So if you want to switch and do all these things, you don't have to keep changing your code again and again. Okay, that's the whole point, because every LLM that you use, it will have its own syntax, it will have its own code. The way you are using OpenAI API, same way you cannot use Gemini, same way you cannot use Claude. They will have their own interfaces, they will have their own methods. But if you bring them all together inside Langchain, then once you have imported that and you have created this LLM object, then you don't have to worry about their individual code, because Langchain will provide one abstraction and it will provide you a consistent interface no matter which LLM you are using. So LLM becomes like one pen drive, right? Whichever brand of pen drive you buy, it will all be connected to your laptop using the same port. It is very easy. It's like C-type charger. Whichever phone you have, whichever C-type charger you have, you can plug it. So similarly, this will provide a consistent interface, or we call it as a abstraction, so that you can use these LLMs in a much better way, and your entire chain and the code, everything you have written, you don't have to tinker all of that every single time. Okay, so that's it for today, guys. We'll stop the session today, and we'll we'll tomorrow we will learn about, in the next class we'll learn about chunking, embedding, and using vector database. I wanted to cover this also, but time has run out, so we will do this in the next class. Okay, let me stop the session now.